acceleration down the incline. The problem is we are given an inclined plane fixed to the ground, and the coefficient of kinetic friction mu k is also given. So this inclined plane is fixed to the ground, and the mu k, the kinetic friction coefficient between the block which is sliding on this inclined plane and the inclined plane itself is mu k. That is the coefficient of friction. A mass m is sliding down the incline, and compute its acceleration. The plane makes an angle theta with the horizontal. So the plane is making an angle theta with the horizontal line. This is the situation. To compute the acceleration of m as it goes down the incline under the action of the friction and the other forces, we need to first get the free body diagram of m. In a free body diagram, which we show here, we isolate the body from the system and replace the other objects by the forces they cause on m. So m has been isolated and shown here. The reaction force caused by the inclined plane is r. It's acting upward on the body. The weight mg is acting downwards at the center of gravity of the mass. So we have chosen a coordinate system. This is the axis which is parallel to the incline, and this dotted line is perpendicular to the incline. So that is the coordinate system in which we will solve this problem. We have shown the reaction force which is upward to the incline, and the mg force, the weight or mg force, which is acting downwards. So we can now, there's another force, the frictional force is acting upward up the incline as the body itself is sliding down the incline. So if we resolve mg into forces perpendicular to the incline and parallel to the incline, you have mg cos theta, which is acting perpendicular to the incline, and it's balancing the reaction force, and mg sin theta is causing the acceleration of the body, while the friction is opposing the acceleration of the body. So this is the free body diagram and the various forces acting on the body. Let us now write the equations of motion. So motion down the incline is given by the force, the net force on the body down the incline must be the force which is causing the acceleration of the body, isn't it? So mg sin theta is the force causing motion, and the frictional force which is up the incline is the force opposing the motion. So under the action of these two forces, the body is going down the incline. So mg sin theta minus the friction must be causing the acceleration of the body down the incline, ma. And motion normal to the incline, there is no effective force normal to the incline. So the reaction force is balancing the mg cos theta, the component of the weight along the normal to the incline. So r equals mg cos theta. Now when we apply the law of friction, we get that the frictional force value, the magnitude, is kinetic friction times the reaction force. So this is a consequence of the law of friction. Because the body is sliding down the incline, the coefficient of friction which we must apply here is the kinetic friction, not the static friction coefficient. So, and the angle theta is larger than the angle of friction. So all of that is taken from the law of friction. So Fr equals mu k into r. So the equations 1, 2, and 3 may be solved. First by putting Fr into equation 1, equation 3 into equation 1, using equation 2, and solving for r, we get a as g times sin theta minus mu k cos theta. So interestingly, this acceleration is independent of the mass m.